Thanks everybody for joining. Today I'm going to be discussing some kind of personal project that I've been working on for the past year, looking at Punkbuster. Who here is familiar with what Punkbuster is? Nice. So, a bunch of gamers in the room, always good. If you look up how people, or what people think of Punkbuster, there's a great site called urbandictionary.com. Put in Punkbuster, you'll get a very nice description of what Punkbuster is. So, a little bit of information about me. I work for Veracode based in the States, but actually live in Japan. I've been there for about 7 years. Prior to Veracode, I worked at Symantec. The only reason I worked at Symantec is because they bought out Stake, so I was kind of forced to work there. But they did send me to Japan, so I appreciate that. My job or my duties are more of researching web applications and attacks and things like that. Not a lot of reverse engineering, anything like that. So this project for me was more to get my hands kind of dirty with various, I almost want to say malicious software. So Punkbuster is installed in a number of games. Probably the biggest customer of them is Electronic Arts. They have the Battlefield series, which has supposedly over 50 million subscribers. Their free-to-play service only has about 5 million. They use Punkbuster as obviously their primary anti-cheating service. Punkbuster was developed by a company called Even Balance in Austin, Texas. They are not a very well-liked company, either of them actually. So before I get into the real details of it, I just want to sort of highlight the primary components of Punkbuster. So for my target, I chose Battlefield Play for free. The primary reason being it's free and I didn't have to give EA money. So I chose them as my target. And although Punkbuster is installed in all these different games, they are a little bit different. They use different versions. You can actually go to Even Balance's website and look up which version is installed with which particular game. So when installing the game, first it'll install, when it installs the Punkbuster components, it'll install Punkbuster A. Punkbuster A is just a loader service. Its primary purpose is to manage Punkbuster B. So Punkbuster B is both of these are Windows system services. Punkbuster B is kind of the more invasive, interacts with the operating system, scans memory, scans processes, things like that. And this is all communicated by the pbcl.dll over UDP. Both of these services are communicated over a UDP locally bound socket. The game itself communicates with PBCL using a shared data structure via 2 exported functions. So that's how the game communicates with the Punkbuster client DLL. So as I mentioned, Punkbuster A loads and manages Punkbuster B. It's a standard straight-up Windows system service executable that's installed. It has no anti-reverse engineering functionality or techniques or anything like that. It is bound on 44301 UDP, localhost only. You can't communicate to this over the network or anything. It accepts commands from the PBCL, as I mentioned before, over UDP. And while the game is running, once it starts the Punkbuster B service, if the game is closed or exits, it's told to unload Punkbuster B, and this is all under the control of Punkbuster A. So these commands, a little hard to read. There's 4 commands that are accepted on Punkbuster A. These, again, sent from PBCL. The first one is the load command, and all of their commands are just ASCII null terminated strings. The first byte is the command, so L for load, and then a path to an executable. I'm sure you're all thinking now we can just throw in any executable and have it installed as a service and executed, but they actually verify using WinVerify Trust that the executable is signed with their signature, and they do check the various properties of the certificate to make sure that it's safe to load. The U command just unloads Punkbuster B. The V command will give you the version information back in a string. In this case, they're currently running V1036 for Battlefield Play for free. The M command is probably the most interesting. The game client will tell the process ID of the game to Punkbuster A, and that's the first parameter. The second parameter is the base address to read from. using read process memory. And then the third parameter is the size, how many bytes to read. So again, you might be thinking, well, we can just supply any PID or process ID, have it read X amount of bytes, and then to a disk, it actually saves it to Windows System 32, Punkbuster b.xtr. And in version 1033, which was probably about a year ago that they upgraded to 1036, you could actually do that. And I found that you could just access any 32-bit application, supply a base address, supply a size, and then dump it to disk. But they've changed that to now check. They do an open process. They make sure that the module pbcl.dll is loaded and that there's a specific string that exists within that module. So they protect against dumping arbitrary memory. One thing I do want to mention, when it loads and manages Punkbuster B, when you try to actually do your analysis of Punkbuster B, it's kind of hard if the game is uninstalling and reinstalling it every time the game starts. So I had to come up with a way, and this is actually my first kind of obstacle, to allow me to automatically run Punkbuster B either in a debugger or Intel Pin Tools, which is a binary instrumentation framework. So I had to come up with something, and I came up with Funkbuster. And this is kind of I have a bunch of different tools that I make, and I just have this moniker or name or whatever for my Funkbuster A, my Funkbuster B, and my Funkbuster client, things like that. So this gave me control of how Punkbuster B was loaded and managed. It emulates it pretty much perfectly. But I can ignore things, or I can install the service as, for example, under a debugger, or I can install it using pin tools, so I can load the Punkbuster B in a pin tool to help my analysis. So that was probably the first step that I needed to kind of overcome. So the Punkbuster B service, again, Windows system level service, it does contain anti-reverse engineering techniques. They have string obfuscation, function pointer obfuscation, a segment in the data section of the Punkbuster B module or executable that's all obfuscated code, junk statements, things like that. It also listens on UDP port locally bound 45301, and it has about 30 commands that it takes in from PVCL. These commands, again, are anything from scanning processes or reading memory or creating signatures or scanning for signatures, things like that. So their string obfuscation is basically just a function, and you call throughout the application, it'll call these functions. There's about 5 bytes, again, it's kind of hard to see. There's about 5 bytes that are their key that they XOR each individual byte of the string with, and then they return the unXORed string as a pointer from the function when it returns. So I wrote a tool, I had a Python tool to basically load Punkbuster B as a module so I could call these individual functions, and then when it returns the string to me, I just output it into IDA. So here you just click anywhere within the function, run this little decoder tool, and it'll print out the top of the function, the results of the obfuscation or the deobfuscation. So that worked really well for me. But I needed to do a little bit more analysis. So how many people here are familiar with pin tools, Intel's pin tools? I don't know if you. So it's as I mentioned before, it's a dynamic binary instrumentation framework. It allows you to write these tiny little tools that you can use to instrument an application any way that you want. It's extremely powerful. It runs almost like inside of a VM where you can control, for example, what registers are read. You can hook functions. You can do detouring, things like that. One thing that I really wanted to do when I started looking at the obfuscated code is to kind of determine what parts of the obfuscated code is being called. You can't really sit there in a debugger and go through this step by step because there's thousands of just junk instructions. So I posted on Twitter that I was looking for a tool like this. One of my friends responded, said that there's a guy named Derico that created a very similar tool. And his tool, for some reason, is having problems with it, so I decided to kind of hijack his idea and create my own. The way it works is it creates basically a bitmap of the executable that you're doing your analysis on, and then every time an instruction's hit, it just flips the address of where that instruction would be. So what you get is you get a way to determine how often something is called, so that's what the colors represent here. The first band is just instructions that were only hit maybe once or twice, so it's a very light shade of blue. The second band in the middle is instructions that were never called. It's just the default IDA, or my default IDA theme. And then it gets a little bit more instructions probably hit maybe in a loop, so it would be a much darker blue. So pin tools really helped me understand how this obfuscated code was being called, where it was being called, and how often it was being called. So that was, again, really, really helpful to have. The other thing about the tool that I wrote is I made it so you could have a start instruction, so it won't start logging until it hits that instruction, and where it stops. So I can reduce if there's a particular command that I'm interested in. I can say, okay, I know this command is called at this instruction, and it ends here. I just want to see when it jumps into the obfuscated code, and I can get my highlighted code or visualization of what was called that way. It's just kind of a fancy hit tracer that allows me to visualize it. The next tool, the pin tool that I wrote, was kind of a net logger. It basically just hooks the receive from and send to UDP functions. So the client is sending to the server, so the receive from, obviously the server is receiving. The first thing that you'll notice is that there's this A and then 8 bytes afterwards. So again, just like Punkbuster A, the first byte is the command, and then anything follows is either data or parameters or things like that. In this case, the first thing that's sent by the client to Punkbuster B is the handshake. And this handshake value will change depending on the version of Punkbuster B. The second command, or the response to that command, is part of a challenge response. They generate these session IDs. Again, this is all locally bound, local host interface traffic. It uses a Mersenne twister with get tick count as its kind of a seed value to create a random number, and then it responds to the client with that. The client then needs to take that challenge and formulate the response by using a very, very simple arithmetic of multiplying a constant by the session ID subtracted by another constant. Pretty basic stuff. And then it responds with the H command with that response value. The next send to from the server to the client, it's an MD5 sum. It is generated by taking 5 or 6 constant values, string concatenating them, and then also including the name of the game inside of it, along with that session. They have another kind of arithmetic equation that they use to create another random value, and that's all MD5 summed and returned. In Punkbuster, for those who are familiar with Punkbuster, they have a way of doing global bans. This where they would take either hardware information and or your username information, they would just ban you outright. If you were found cheating, they would have these GUIDs that they would be able to use to ban you. This actually isn't it. This is just I don't even know why they do this, but they create this hash and then they send it back to the client. So the other interesting thing is after seeing all the challenge response and the hash being sent back, I started to notice that the E command looked kind of like gobbledygook. There was no sense to it. And obviously, most of you realize it's probably encrypted or obfuscated in some manner. And indeed it was. They created their own encryption algorithm for this localhost traffic. Again, I have no idea why. But so that was kind of my next kind of obstacle. It's like, okay, obviously something sensitive is going across these commands and I need to be able to decrypt it. So doing the usual technique of setting a breakpoint on the receive from, following the code in IDA, following the code until I see something that looks like an encryption or decryption routine, and then analyzing it from there. And this is pretty much their encryption and decryption routine for that particular, the E commands. All of their commands are kind of, they have like E commands, S commands. They all have some sort of kind of pattern that they follow. But here, this is the challenge response equation I was telling you before that's part of the hash. This is the values right here that they use with the key. The G key is that session ID. So they have this random kind of operation, and then it's XORed with the length of the buffer. So anytime you send data to Punkbuster B, you have to have the correct buffer length that matches your data, otherwise it'll decrypt improperly. The rest of the algorithm is kind of just multiplying, shifting, and then adding and subtracting, nothing crazy or fancy. Again, I have no idea why they came up with this. I assume it's just to waste someone's time, and I guess it did a pretty good job because I spent about a day on this. So that was their algorithm in kind of their format of assembly. I had to obviously change a bit of it to get it to inline with Visual Studio, but I wanted to redo it in C. So I redid it in C, and it still looked pretty nasty or gnarly or whatever. So I wanted to make it even cleaner. And this is kind of the end result. There's two kind of operations. They create this using the key information. Again, they're iterating over the buffer, each character one at a time. They have this subtraction byte and this addition byte that they use to formulate the result that will be either added if it's decrypting or subtractive if it's encrypting for each character in the buffer. So at that point, I'd been doing my analysis of Punkbuster B pretty heavily. I hadn't really looked at pbcl.dll at all. Punkbuster A I completely reverse engineered because it was pretty tiny. Again, there's only 4 commands. So I wanted to kind of refocus myself on what the client DLL was doing. And as I mentioned before, it exports 2 functions, and I wanted to kind of see how that data was being used by the game when it communicates back and forth with the DLL. So I used API spies. I took a look at how they have their monitoring kind of XML format for hooking these functions, and I created my own to allow me to see while the game is running what type of traffic was being sent back and forth. The CB command is kind of the one of interest. It contains this data structure, which I don't fully understand yet, but I do understand some of the parameters that are passed. And it has these flags and command values. And this is pretty much what it looks like. It's going to be really hard to read. But up here in the top corner, you can just see that it has various numbers that it uses with each command. And then down here, you can see the pre-call value and the post-call value, which is extremely helpful for determining how the game client, when it returns back to, or how the PBCL DLL, when it returns to Punkbuster B, what the values changed, how they changed. So if they're passing information back and forth, it's extremely helpful to have this pre-call value and post-call value. So this is going great. I was figuring that it wouldn't take me too long to understand how all the traffic worked. And I was running the game. I was not really playing the game, but letting the game run. And then I got kicked. They apparently checked that if you are hooking the CB or CA functions. So I got kicked and banned from that particular server. The one thing I do want to note is when I was doing my analysis, I was running in VMware, and I used a VPN service. The way that Punkbuster or Even Balance bans people is with these global IDs, as I mentioned, and it takes information from your hard drive, the serial IDs, and the Ethernet MAC addresses, and it creates hashes of them. So to kind of protect myself from getting globally banned, I used VMware and I used a VPN service, and it worked out really well. So now I want to talk a little bit about the obfuscated code. So I am not a malware researcher. I don't encounter this type of stuff like ever. So this is pretty new to me. It looks like they have some sort of like command structure where they jump to this segment of code, they'll push a value and then jump back into the obfuscated code. Here I noticed I took some notes of what they were doing when they were calling get proc address to get various function pointers and things like that. The code itself is, again, just junk statements. There's a lot of shifting and XORing, subtracting, adding, things like that. And at this point, I was kind of almost about to give up because it had been a couple of months, and I'm like, oh, I don't understand this. I don't know what it's doing. I can't sit there in a debugger and kind of figure out what it's doing. So I was pretty much ready to give up. And then I started to realize it's kind of like just looking at a wall where it looks like it's very far away or it's unattainable, like you can't get there. And then one night during some bout of insomnia, I was thinking, it's like, well, I don't really care what the code does. I care more what it does with itself. I care what it calls and what it writes to. I want to know what data is being written, and I know exactly where data is going to be written, especially the obfuscated function pointers. I knew they were being using load library and get proc address to get those. I just didn't know where they were storing them. So using that kind of that thought process, like, okay, I want to look at it from a different perspective. And things started to turn out to look like steps. It's like, okay, I think I can figure it out. I just need to write a tool, a pin tool that allows me to analyze the reads, the writes, and the calls outside of the obfuscated code. Again, I don't care what happens inside, I only care what happens outside. And this led me to writing my tool, Ninko. So in Japan, foxes are kind of mythical creatures. They have the ability to turn into humans. There's various stories of them. One story is the story of Ninko, which is, if you read the English Wikipedia site and the Japanese Wikipedia site, they're totally different, but I'm gonna use the English one because it actually backs up what my tool does. So Ninkos only can be seen if you're possessed by them, which I thought was a really kind of good way of looking at this. Like I don't know what the obfuscated code does unless I possess it, and I'm gonna possess it with pin. And that's pretty much how my tool works. So Ninko allows me to log all the calls, jumps, returns, any sort of instruction that occurs. I can specify, obviously, if I want to hook functions. I can specify where data writes to data that I care about. So certain ranges I can monitor to see what values are being written there. And I can also ignore certain instruction. Maybe there's an instruction that always writes the same value. When you're doing anything with pin, especially if you're looking at a lot of instructions being called, you just get inundated with information and it just becomes useless. So to have all these kind of commands that allows me to reduce the amount of information that I'm looking at and allows me to focus on exactly what I need to know about what this code was doing. And again, you can specify the code start. So in Punkbuster's case, they have their obfuscated codes in the data section from a certain range to a certain end range, and I can just say, okay, I want to monitor any reads or writes that happen at that range. And the same with data. If I only care about a certain range of data that's being written to, I can specify that as well. And this is pretty much what the configuration file looks like. You can turn on and off pretty much everything, whether you want to only read, log reads or only log writes, etc. And running it's pretty simple. You just use the pin T to load the tool, and then you use the configuration. And you can specify different configurations, obviously, so it's very, very helpful. Now, as for the output, initially it has just validates the configuration, makes sure everything's okay, tells you all those addresses that were in the config are added to the base address. So once the module is loaded, as long as you have the offsets correct, it'll be added to the base address, and you'll have the correct location of code. So here's what it actually looks like. So the first two kind of characters are whether it's a call, read, or write. Second area is the thread, the instruction pointer followed by the disassembly, then the target that's being called. If there's symbols, if you're lucky enough to have symbols, it'll put that in there, all thanks to pin. And then for the writes, it'll give you the effective address of where it was writing to and the data that's being written there. And it can do bytes, words, D words, quad words, etc. So that helped me understand how their obfuscated code was being used, but I still didn't really understand how the pbcl.dll and Punkbuster B were communicating. I mean, obviously I know it's going over UDP, but I want to see what type of commands is it sending back and forth. At this point, I've already reversed a number of the commands, so I kind of knew what was going on, but I wanted to see how the game was doing it. And that led me to create this tool called UDP-DP, which is just a decrypting proxy, man in the middle. The interesting thing about it is it allowed me to create decryption DLLs, either managed or unmanaged in .NET. And I can specify the source port or where I want the traffic coming in, and then the destination port where to forward it to. And there's also another tool that allows me to take the log files from that. If I just want to do debugging, it made it easy to replay that traffic information and decrypt it using my DLLs. So this is pretty much what the game looks like when I'm running it. Up in the top, I start Punkbuster A. I say, hey, once you get the command to start Punkbuster B, start my proxy instead. And it was kind of a timing attack with that registry key where I had to start it and then set it to my port instead. And then I was able to basically capture all the traffic going back and forth. And here it's just going through the game with me capturing the traffic, alternatively logging it to a file if I wanted to look at it later. As you can see, the communication isn't all that often. It's pretty lightweight. It's not a lot of polling going back and forth. It's mainly sending these 2 or 3 commands over and over again. It doesn't always like try to grab your hard drive IDs. It doesn't try to scan memory using these commands over and over again. Actually, the initial command is the one that kind of kicks off an entire process of scanning your entire process list and scanning all your the memory. So now that I had a good understanding of how how the game was communicating with Punkbuster B, I created my own client, so my Punkbuster client. And what you see here in the bottom left-hand corner is a fake game. It's basically just an executable that I had to load in pattern data. So you can almost think of Punkbuster as being like an antivirus where they're searching for known signatures and hacks. And the way they do this is they have this range in the game that specifies all the patterns. And if this range, when it communicates to Punkbuster B, it says, hey, you can find all this pattern data at this address, so do a read process memory and grab that pattern data, and then you can search on your own. So I had to create that fake kind of client to kind of trick it into thinking it was a legitimate game that was running, because I didn't want to play it. So here I'm just installing Punkbuster B as a service, just using SC start to start it. And then the first thing that I need to do is do the handshake and get a session ID, which you can see here. And again, it sent the server hash response, and that was it. Obviously not too interesting, but it was a start. The next thing is being able to get the hard drive serial IDs and the MAC address ID information. So for that, you need to use 2 commands. First, you need to start with QC. QC is the initial command that will load that pattern data as well as supply other parameters such as random numbers that were generated by the client that need to be reused by Punkbuster B. And then the second command, QH, just says, hey, give me the hard drive ID stuff. So when you send the QC command, the first thing that you need to specify after the QC is 45, which is the number of patterns that are going to exist. The second parameter after that is the process ID of the game. The next 5 D words are just random values that were chosen. The last D word value is the address in which you need to find the pattern data. So you can see it's 00AF, and then down there in the bottom left-hand corner is 00AF. And then the final parameter is just the size of the pattern data. So 6880 bytes of data. And what you'll notice is it returned HSA and then a bunch of zeros, and then a TA and a bunch of zeros, and then M followed by an MD5 sum. It turns out when you're running Punkbuster in VMware, they can't really get your serial ID, so it just returns with all zeros. I imagine if you're a cheater and you wanted to not get globally banned, this would probably be pretty helpful. The adapter information obviously was accessible, just uses get adapters info to pull that MAC address information, and then it creates an MD5 sum. But it's not a generic MD5 sum. They actually modified how MD5 works. They have specific, like a modifier parameter that they can pass to the MD5 init function. So there's a number of constants in MD5 that are, when you initialize MD5, it has these values that it supplies for a structure. And they added this modifier so that they can call MD5 sum with different modifiers and get different hashes, which totally threw me through a loop at first, but I figured it out after a while. And then, to make matters worse, I found out they actually released the code on their website that has all that information. I forgot to look for it. So always do your research. So that was pretty interesting. The next command is looking up the processes. And here I need to send the QC command to get that, to make sure it's talking to the game client okay. The SC command is actually yet another encryption algorithm they use, very similar to the previous one, but you need to send the SC command to get another session, another session ID for any S commands. So all the S command series require you to encrypt in yet another encryption algorithm. And then the SP command will just kind of kick off a process saying, okay, Punkbuster B, scan every single process that's running using what enum processes or whatever, and create a data structure of that, and then I'm going to keep polling you, and you're going to send me all of the processes that are running. So while it's doing that, you see here the parsing key. So I need to, again, start decrypting using this second algorithm. So you need to encrypt the first time and then the second time. And then it gives me the number of PIDs, which is 45. And then you just keep calling it, and it'll keep telling you all the PIDs that are running. What's interesting is that Punkbuster is only 32-bit. So it can't access any of the 64-bit processes that are running. It can't scan the memory of them. It can't do any of that. So again, 32-bit it's pretty much locked to that until they upgrade. You can see the final thing, PID 6, or a PID, it gives you the PID number, the base address of that module, and then the module name, or the image name, I guess, which is just my recording software. And then there's the M command. So again, got to send the QC, SC, and then SM commands. The SM command basically will give you a list of modules that are loaded for that process. And it gives you the size, the base address of all the modules that are loaded that have image names. So here we can see module 3 has a base address of 7718, blah, 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 the size, and then the name or the path. So a little bit more deeper information. Then there's the SB command. The SB command allows you to get a lot more information about a process. It basically gives you all the memory, the mapped pages in memory. It gives you the size, the base address of that page, and then the attributes of that page. So if it's a read, write, or guard page, anything like that. And then if it has a module name or path, it'll display that as well. And then probably the most interesting command would be the, I think it's the SF command. This lets you just dump memory, which I thought was pretty awesome. You need to specify, it only reads from the base address of that module, but it will, you can call it any number of times and have it dump that data. And obviously there's a million uses for that. So that's pretty much how these commands work. There's tons more information, tons more commands. This is only a subset of those. There's ones for controlling patterns. There's one for controlling the process itself. You can unload Punkbuster A, things like that. So how does PBCL kind of work? They also have all the same techniques of function pointer obfuscation and string obfuscation, code obfuscation, etc. What's really interesting is their function pointer obfuscation is a little bit different, where first when the module is loaded, it jumps into the obfuscated code, and then it jumps to this function that creates a function pointer table. So all the functions that they're going to call, they create this table somewhere in the data section, and then they XOR it with a particular value. So you can see here I've reversed a number of these where it just gives me the results of various functions, or maybe I just named them. And actually I want to take a quick kind of just mention briefly that the way that I do my analysis, and I don't know if this is correct or not, but for me it helps to, when I'm sitting in the IDA, I will go through all the functions and I will mark them as something that's either unknown or maybe. So if you see like here, there's PB, maybe PBCL in it. And that really helped me to kind of go through and come up with kind of the list of, okay, I know what this function does, so now I'm going to remove the maybe, or maybe it was unknown before, and now it's a maybe, calls this function. And it really helped me kind of just narrow down as I was working with these DLLs, or these modules. So the way that they look up these values is they use yet another series of XORing to constant values. Here's kind of the algorithm for it. They just have two registers that get loaded with addresses. They XOR them or subtract them, which gives you the index into the function pointer table. Multiply that by 4 because it's a D word, and then you get the actual function call, and then you call it. So here is just looking up the PB query registry, get Punkbuster B port. So to do that manually would obviously take forever. So I wrote yet another IDA Python script to basically allow me to select a certain range of those where those XORs were occurring, and then automatically give me the address of them. So this function right here is the screenshot function. Punkbuster servers can tell the client to take a screenshot of their client's desktop. So this is just one of those functions. So here I've looked up the create string. This is the actual table itself here with all the various function pointers. Then I just jump to it, and then I can just repeat the process, and I can select as much as I want to. Again, it would probably be easier if I just ran through an entire function and did this, but I kind of ran out of time. So, but it helped a lot to, when you're doing this analysis, if you're looking at a function that has just hundreds of these XORs going on and on, to be able to automate that was extremely helpful. Now, if you remember, I got kicked for hooking. So there are hooking routines or hook checks. Basically, from what I can determine anyways, that they consist of passing a function, the function that's going to be checked, and doing a mem copy of the first 8 or 9 bytes. Sometimes it's more, it depends on the function, but for the most part, it's usually 8 or 9 bytes. And it calls, you can see this is pb call memcopy 3. There's actually like 57 of these. So I don't know why they didn't just do it in one function. I guess they wanted to spread it out. But throughout the game, it will call these and do these mem copies. And yeah, so don't hook the first 8 or 9 bytes. Another thing to note is the junk bytes. Each one of these mem copy calls will basically contain some jump statement that will never occur. And it's totally there just to throw off static analysis tools. And when I first started, since I wasn't, I mean, I've done reverse engineering before, mainly for memory corruption stuff, but I used the pseudocode plugin for IDA, and it totally choked on this, and it was giving me all these kind of bad information. And when I first started doing my analysis, I was actually thrown off by a number of their junk statements. But after a while, I figured out what was going on, and yeah, so that helped. So what do I have left to do? Automatically deossificate the code would be great. I know there's a guy at Cozinc who created Opticode, which basically will take x86 assembly, run it through LLVM to kind of condense it, and then recompile it back into x86 so you can remove, it uses the optimizer to remove all the junk bytes. So that might be something that I'd like to look at. Decrypting the PBCL to the PB server. So the game client, while Punkbuster B doesn't communicate with even balances services, PBCL does. And they have, again, their own custom encryption algorithm for that. I've identified where it is. I know how the key is generated, but I haven't created the tool to automatically decrypt it yet. The Battlefield Play for Free executable in the game structure, I still need to work through that a bit as well. There's, again, it's like 1,000 bytes of various variables that I need to go through. But figuring that out would probably help a lot, because they are using encryption. Even in the function calls back and forth, they're encrypting that as well. There's a number of HTML files which contain kind of known hacks. Not signatures as much, but from what I can tell, it just contains modules that they need to look for in the game directory, along with a hash that goes with it. And I've identified a function that is basically called throughout the game that checks or decrypts these values and allows you to see what modules it's currently scanning for. But I did that in a debugger, and they have some anti-debugging tricks to basically crash. So I still need to do a little bit more work on that. And of course, there's no guarantee I'll do any of this because I've been working on it for a while, and I might need to do something new. So we'll see. That's pretty much my talk. If you feel like this hasn't been technical enough for you, right after this, I'm going to release a wiki page about, if you printed it out, it's probably 30 pages of just all the commands, the patterns that are current for this version, pretty much everything I've talked about and a lot more. The Ninko tool is also going to be released on my GitHub page. And I just want to thank my company, Veracode, for allowing me to spend some of my 20% research time on this personal project. And of course, 44Con for flying me out here. So thank you. Any questions? Any questions? Am I going to release which tools?
Punkbuster and the one before.
Ninko will be released. I'm going to do that like right now after I get off stage. The wiki will be released. The other tools have been released. I'm still contemplating releasing the Punkbuster tools, but I might. Let's put it that way. Any other questions? All right. Thank you very much.